You're welcome. Okay, so we're gonna go over the quiz number 3 today. Let me see. All right, I'm gonna share. Okay, quiz number 3. Okay, and so now question number 1, the maximum amplitude of an AC waveform in either polarity is the answer is C as in cat, is the peak amplitude. Okay, so if you look at either, you look at the positive side of the signal here. Okay, so if you look at the positive peak here, it's a V peak, or you look at the negative side of the peak, and that's still V peak. So it's a peak amplitude, okay? And that is from the handout, the AC fundamental handout, page 1. Okay. Number 2, one complete repetition of an AC waveform is, okay. So that's represent a cycle right here. So it goes 1 and it comes down. That's one complete. And that's what we call a cycle. Okay. The answer is C as in cat for number 2. Number 3, if the voltage peak of a sine wave is 70 volt, then the VRMS is, okay. So we want the peak. So it's from here to here is 70 volt. So we're going to take the 70 volt times the 0.707, and that gives you 49.49 VRMS. So the answer is B as in Bob for number 3. Okay, any question number 1, 2, or 3? Okay, next set. Okay, number 4, for the time constant of a circuit containing 100 kilo ohm resistor in series with a 20 microfarad capacitor. Okay, so we want to find the time constant. So we got the R is 100 kilo ohm, which is 100,000 ohms. And C is 20 microfarad, same thing as 0.00002 farad. So your tau or time constant is RC. So 100,000 times 0.0000234, one more zero. Okay. Farad should be, if you multiply that together, you should come up to 2 seconds. So the answer is A and as an apple for number 4. Number 5, when the phase angle is measured by an oscilloscope, a lagging waveform is, mainly the lagging is going to be the one to the left of it, because it's, so as you can see, the blue one here, this one is the blue one comes first, and it hit the line here first, and then after that, the red one hit that line. So the one that's shifted to the right is the reference point. So shifted to the right of the reference point. So to the right. So this is shifted to the right. So this is your blue one is your reference, and this is your lagging signal. Okay. So the answer is C as in cat for number 5. Okay, an oscilloscope can directly measure AC as well as DC. Okay, so this is from the first handout. Okay, so this one here, you can put DC, you can put DC coupling, and then you want to change your signal to VRMS, and then you should be able to measure a DC signal. But if you put into AC coupling and you put into V peak to peak, you will get a sine wave signal, or sine signal. Okay, so the answer is A as an apple for number 6. So number A, any question number 4, 5, or 6? Okay, no question, next set. Okay, the reciprocal of a frequency of an AC waveform equals to the period. The formula is that T equals 1 over F, and same thing, T is represent the period, and 1 F is represent the frequency. So the answer is period. So the answer is D as in David for number 7. Number 8, which oscilloscope control setting is used to measure time? Okay, that will be the time domain or time base. So the answer is D as in David for number 8. Number 9, the equation XC equals 1 over the quantity 2 pi FC is valid for, mainly it's going to valid mainly for just the AC, just for the AC signal or the sine wave only. Okay, so the answer is D as in David for number 9. Okay, any question number 7, 8, or 9? Okay, no question, next set. Okay, capacitance is the ability to hold charges. So the answer is D as in David. As you can see, your capacitor. So this is your capacitor. So this voltage of the capacitor, it's able to hold that charge. So at the first time constant, 63.2%, then 86.5%, 95%, 98.2%, and this will be at the 5T, that will be 100%. So the answer is D as in David for number 10. Number 11, a capacitor considered to be fully charged after how many time constant? So you look at this one right here, it's got 100% right here, so therefore it's 5 time constant. So the answer is C as in cat for number 11. Number 12, the capacitive reactant XC lie on which axis of XY coordinate plane? Okay, so it's going to be, mainly it's going to lie on the Y axis. Okay, as you can see right here, XC. Okay, so XC is lie on the negative Y plane. Okay, so negative Y. So the answer is B as in Bob for number 12. Okay. All right. So any question number 10, 11, or 12? Okay. Yeah, if you still have difficulty with these quizzes, you can always go back to the handout, use the handout. Okay. Okay, 13, the transfer of energy from one circuit to another is called a coupling. So that's B as in Bob for number 13. Okay. Number 14, the time constant RC specified times the C to charge to what percentage of the charging voltage? Okay, so your first T would be right here. It represents a 63, represents 63.2%. Okay. Okay, so the answer is B as in Bob for number 14. Number 15, a very common use of the capacitor is to, okay, mainly, so it let AC through, but it's mainly, its objective is to block the DC signal, okay? So the answer is B as in Bob for number 15. Okay, so this is talking about here, time constant. Okay, time constant. So time constant is time for capacitor charge 63.2% of the maximum value. Okay. Okay, any question number 13, 14, or 15? Okay, no question. Next set. Okay, so the other, yeah, so this one has been fixed on number 15. Like I said before, we got the two number 15, but this one's supposed to be 15, and this supposed to be 16 right here. Okay, and then we throw away the one that's at number 18. So this one is recorrected, so everything is correct. So what is the total impedance of ZT for the above circuit? Okay. So you apply the formula for ZT. ZT equals the square root of the quantity R1 square plus XC square, okay? And if you apply that formula, the answer comes to 216.3 ohms. So the answer is A as an apple for number 16. Number 17, what is the total circuit, total current IT for the above circuit? Okay, so this is going to be a series circuit. You're going to have one current. So IT equals to E divided by ZT. So E in this case is 50 volt divided by ZT, 216.3 ohms. That comes, and that will come 0.231 amps, same thing as 231 milliamps. So the answer is C as in cat for number 17. Number 18, what is the capacitor VC for the above circuit? Okay, so we got voltage of the voltage of the capacitor. Okay, voltage of the capacitor equal to IT times XC, so 0.231 amps times 120 ohms. That yield 27.73 VAC. Okay, so 27.73. So the answer is A as an apple for number 18. Okay, any question number 16, 17, or 18? Okay, look like everybody got it. Okay, nobody will have any question? Okay, I'm gonna stop. Okay, so now we'll take any question of anybody that needs some help on the homework or anything. If you have some difficulty, go ahead and bring it up, and so we can help you now. Okay, so just make sure you unmute yourself if you want to chat with us. If not, you can always write it in the chat. I can always see it. Okay, look like no one have any question. Okay, back to you, Mr. Pham. Thank you.
Thank you, Sam.
You're welcome.
Okay, hello everyone. Do you have any question in the program? Just let me know. Okay, if it's not, let me using my iPad. Okay, this time we start with the RCL circuit. That will be get the very short series RCL and parallel RCL. Okay, so the first thing we're talking about series RCL circuitry. As you can see, this is the series R1 30 ohm, C1 XC 60 ohm, L1 XL 20 ohm. When the circuit combines RCM in series, ohm series reactant XC and XL, you combine the net reactant I. That means the difference between XC and XL. And in the past, you already know, you cannot solving the circuitry with both XC and XL. Okay? You have to come up with a new circuitry. They will be L or C only. For the series circuit, you're looking for XC and XL. See which one will be bigger. For example, here, XC 60 ohm, XL 20 ohm. So now you need to calculate the net reactant. H will be equal either HC minus HL or HL minus HC, depending on which one is bigger. If HC greater than HL, the circuit is capacity reactant circuit. Or if HL greater than HC, circuitry now will be inductive. For the circuit so H equal HC minus HL equal 40 ohm. The new circuit is capacity circuit. That's what you see. That's the new circuit. Okay? Now we're looking for the new RC circuit. If they want to calculate the total impedance, then you can see R1 square plus H square. And I given you the answer, 50 ohm. Then you calculate the total current. You take the total voltage, divide total impedance, get 2.4 amp. And you calculate the voltage across the R, okay? IT times R, you get 72 ohm. If you want to calculate the VC or VL, you have to go back to the original circuit here, okay? VC equal IT times HC. HC is 60 ohm, 2.4 amp. Okay, you get 144 volt. If VL, IT times HL, 2.4 times 20, you get 48 volt. And finally, they want to calculate the phase angle. Okay, and that will be equal minus 10 minus 1 minus H over R. You get minus 53. You know this is what we call a phasor voltage triangle. If you draw the VR, then what is the VC or VH? Okay, so basically VC will be likely. That means minus 90 degrees. So that's why you draw that 90 degrees. And when you connect it, you can get the total voltage here is 120 voltage. And this is the angle. Okay. If the trigonometric formula, that's why you come up with the angle theta. So from the number 1 to number 6, any question on the series RCL? Only the difference will be you have to convert it to either RC circuitry or RL circuit, depending on which reactant will be bigger. Okay, any question on that? Otherwise, go ahead and do for me example number 1. Go ahead and do it and let me know the answer. What the X equal? Easy, right?
Yeah.
RCL minus HC. Okay? And the circuitry will be inductive circuit. Okay, go ahead and let me know. Total impedance, total IT, VR, VC, VL.
ZT 112 ohms.
Is it 100?
12
Okay, 101, 112. Correct. Total in total IT. Who get it?
Point 89 amperes.
Okay, 894.4. Correct?
Zero milliamp.
Yeah, milliamp. what we are.
89.44.
Perfect. We say
44.72.
okay, 44.7. VL
89.4.
correct. 89. Okay, triangle.
Negative 26.6 degrees.
26.6 is correct. However, how come you get negative?
Isn't it minus X over R?
But not negative. Okay, now make sure you know how to draw the phasor. Wanted or impeded. How do we do it? First thing, normally they're using R. So you draw VR first. VR will be no phase different. So all the time, R or VR, IR have to go 0 degree. And then you have to draw for VX. VX in this case will be a VL. And if we already go through RL in series, then VL leading VR 90 degrees. So that's why they go up. Okay. Then you try connect this one here. That's a total voltage. Normally the formula will be VT equals square root of VR square plus VX square. And this is the phase angle. That will be positive, not negative. If they going down, then they will be negative. Okay, so any question for the example number 1? Anything confusing, anything not clear, just bring it up.
Mr. Pan? Mr. Pan, if the circuit is inductive, the phase angle will be positive X over R.
That the phase angle will be 26.6, is it correct?
Yes, sir.
Okay.
So if it's inductive, the
Okay, only the difference will be
uh,
what?
phase angle will be
Negative
positive
or
x over r.
positive. If you don't know, have to go back to RL series circuit. Okay. However, again, I try to make sure you know how to draw the phasor for the voltage. But before you want to draw the phasor, you have to know VR, VX or VL, which one will be leading.
Hmm.
From RL circuitry, VL leading VR 90 degrees. That's
Mhm.
why when you draw VR here and VL leading 90, they go up. Okay? That's why you can get the theta here, and you know angle will be positive, not negative. However, if for IC, then IC will be lagging via 90, so they going down.
Mhm.
Okay? So that's why you get negative.
Okay, sir.
Mr. Pham, would you show the phasor example in a sinusoidal graph as an example where the what you just described is what would be the starting of your sinusoidal and the example behind and lagging or ahead? Would you show that in a graph, please?
What do you mean the graphic?
Just draw it out more with the sinusoidal. With the sinusoidal.
Okay, you see that one.
Right. And then
Okay.
wait.
If you want to draw for V, then VR will be go here. The thing is, resistance have a no phase difference. And now the circuitry will be VL. And if you go back to the RL series, VL leading VR 90. That's why they go this way. Okay? And now you convert it into the phasor. First thing you draw for R. Then VL leading 90. Okay? So that one first thing you draw here. VR. VL leading. Go up. Connect that one. You get the phase angle theta. However, if you want to draw the phasor for the impedance or the voltage or the current, you must know which one will be leading or lagging. Otherwise, no way.
Yeah, that's what I was asking. In the sinusoidal form, there's usually two signals, one next to the other. So one's leading and then one's lagging. So I was wanting to see the waveform so that it would be more clarified as to what one would be designated leading and what one would be lagging, and then reference it to VL or VX.
Okay, you have to go back to the RL circuitry.
So just use the
Yeah, they can draw, the sine wave for the VR and the VL or the IL VL, IC, VC. You understand it for RL series, then VL leading IL 90 degrees. And IL and IR or VR, you know, IL, IR only one current. So that's why IL leading IR 90. And IR, VR in phase. So that's why you know VL leading VR 90 degrees. So we have to get the basic for RL circuitry series or RC circuitry for parallel.
Mr. Pham, could I ask you a quick question?
You have to be very, very careful. Understand RC series, RC parallel, RL series, RL parallel. So when we combine it, you're able to understand.
And Mr. Pham, could I ask a quick question?
Yeah,
On your schematic, your diagram here, XL is 100, XC is 50. So when you take XL minus XC, you get 50. So the circuit is predominantly inductive. So since it's predominantly inductive, right away, you know that the arrow on your graph there goes up right away. Isn't that correct?
exactly.
So, and then from there, you know R is on the x-axis, and then the L is on the y-axis. Then you can complete your angle for your angle.
Exactly. What I'm saying is, for this example, I only calculate everything for you. Now the circuitry will be RC. The thing is, XC higher than XL. So you have to go back to working on the circuitry for RC circuit. Basically, same thing here. XL higher than XC. Then now you can get the circuitry only R and L. So you get a series RL only. So that's why I said you have to understand really R, C, RL, either series or parallel. If you cannot get through that, when we go to RCL, a lot of confusion. Okay, go ahead and solve this problem for me. You make sure you can get the right answer. That's a very, very easy. You can get it done quickly. Okay. I look like you may equal 2K. And this will be L inductive circuit. So you want to calculate the total.
I got 2236,
What you get?
2236.
Joe.
Ohm.
Right?
Ohms, correct.
Okay, make sure someone else get the same answer for me.
Yes, sir. 2236.
2.236 kilo ohm.
Right, same thing.
I total.
$8.94 milli. 8.94 milli. Did anybody else get that?
Yes. 8.94 milli.
VR.
$8.94 volt.
VR 8.49, right?
8.994.
94. Voltage.
Right. That's both.
VC.
89.4 volts.
VL. Look like to me.
Is that 106.8? Did somebody get 106.8 for VL? Did anybody get 106.8 for VL?
I came close. I got 107.28.
That's okay. 106, 107. No big deal. Who get the angle?
63.43.
I got the same.
3.43.
63.43.
Let's see. 53.
63.43.
Okay, so phasor voltage triangle. We already did it. That means you can draw VR, VL, VT here. Okay, so basically that cover for RCL series. Again, you cannot solve it. The problem with both L and C, you have to come up with either one, L circuitry or C circuitry. Okay, by compare XC, XL, which one will be bigger? Then you come back with the circuitry only RC or RL. Okay. Up to that point, any question, just bring it up. Otherwise, I suppose you understand. Okay, next one. Parallel RCL. If you're looking into the circuitry, 4 ohm resistance, inductance 20 ohm, capacitance 60 ohm. So again, either parallel or series, we said we cannot solve the problem with both L and C. And you have to come up with either one, inductive or capacitive. For the parallel, if the current IC higher than IL, then the circuitry will be capacitive. If IL higher than IC, circuitry will be inductive. Then you go back to the RLRC parallel circuit. So when the circuitry combine RCL in parallel, reactive branch current can be combined to obtain one net current designated by IH, when the net reactive current IH can be combined using the phasor with the resistor current IR to obtain the total current IT. So the first thing what you need to do, you have to convert in this circuitry to either RL parallel or IC parallel. And the first thing you have to do is calculate the current go to the capacitor and the current go to the inductor. If current IL higher than IC, the new circuitry will be inductive. If IC higher than IL, the net circuitry will be capacitive. That's what we explained to you here. If IC greater than IL, circuit is capacitive circuit. If IL greater than IC, the circuitry will be inductive. Okay, For this one, we already calculate the, let's see, inductive reactance. We're here. Now, I believe you can follow that and do the calculation for me for this circuitry. What I equal? Just 1 minute, then you're able to get that.
Three amps.
RCL.
0.6 ampere.
0.6 amp.
Should be 6. I think that's
Amp.
2 ohms, not
You're right.
20 ohms.
I see.
IC should be 2 amp, and then IL should be 6 amp.
Okay, now. RCL 2 ohm, correct? That will be
I thought
2 ohm, not 20. Okay. So RCL 6 amp. And IX equal 4 amp. And the net circuitry will be inductive. At least we go up to that point. Okay, number 5. What I equal?
Three ohms.
How do we get the new value for the reactant I? You know the answer will be here. However, how do we know?
Net current for the inductor and capacitive is 4 amp.
Yeah,
So therefore voltage 12 divided by 4 is equal to
perfect. Okay. That it come up with X equal V total divide IX. That given you 0. Okay, then the total current.
five amps.
Perfect. Total impedance.
Two point four amp ohms.
So you get 2.4 ohm. Anyone get the same? Let me know. How do we calculate the total impedance?
Voltage divided by the total current.
Exactly. G total equal V total divide to I total. And what the phase angle?
$59.
Well, I said if you want it, you have to go back to RL parallel circuit. I agree the value 53.06 degree. However, to me, you get negative. Okay. And the question from 1 to 8 for the fourth parallel circuit. That I believe the last one. This is easy, right? 1 point IL 1.2 IC 2.4 IC minus IL. Okay, 2.4, 1.2, you get 1.2. And IC higher than circuitry capacity. I want to know answer for number 5.
One 1.7 amps.
What do you get?
1.7 amps.
1.7 amp, correct?
Yes.
New value for I. Who get the answer? How many ohm?
20 ohms.
How many?
20.
20. Correct. Total impedance How many ohm? Basically, G total equal V total divide I total. Try to see you can get 14.40. Oh, forget triangle. You have to go back for the circuitry as the parallel in order to get the phase. For my calculation, 45°. Okay, any question for this example? And you can see on that one, I came from basic circuitry RCL to RC circuit. Okay, any question? If it's not, okay, make sure you download the complex number handout. Reading first. Then maybe will help you to read easy to understand. Now, the one we already talking about, RCL, series parallel. We're solving by the very basic way. However, we can solving by another way. That will be using complex number. If you go to the college university, they will be teaching you using complex number. For the complex number, then you don't care which one is leading. For series, okay, RC circuitry, you know, IC leading VC, 90 degrees. And for RL, then VL leading IL 90 degrees. However, for the complex number, you don't care. When you do the calculation, and you can recognize which one will be leading. Also, the phase angle. You don't have to remember which one is leading. Okay? So, try to understand the complex number and how we apply to the RC circuitry. Okay? So that is the one we already done today. RCL, parallel, and series. Okay? Up to this point. If you get a question, just bring it up. If it's not, okay, Sam, are you ready for the quiz number 4?
Yes, sir. Ready when you are.
Okay, I stop this guy.
Okay. Okay.
Make sure
Here.
they download report.
Okay, so make sure you download the report from the website. Okay, so, okay, here we go. Okay, so we're gonna be slideshow. Start from beginning. Right, the timing setting is off. Okay. Got 1 minute left. Okay, so that's pretty much it. So make sure you upload this into the website before 12 noon tomorrow. Okay, thank you, everyone.
So you get any question, anything? If it's not, good night, everyone. See you next week.
See you on the
Sure.
lab.
Tomorrow we get a lab.
Thank you. Have a good night.
Good
Bye.
night.